Hello and welcome to The Sleepy Scientist, where the stars shine softly. The science is soothing, and the only thing quicker than the speed of light is how swiftly we hope you'll fall asleep. Tonight, we're taking a calm, dreamlike journey through our local cosmic neighborhood, a gentle drift past 8 unique planets, all orbiting the same steadfast star. From Mercury's sun-scorched cliffs to Neptune's frozen winds, each world has its own character, its own peculiarities, and a touch of wonder. No need for a spacesuit, just a cozy pillow and maybe a warm cup of tea. Before we begin, a small, polite heads up. While this video is designed to help you unwind and rest, there's a small chance it might be a bit too interesting. If you find yourself wide awake, pondering how Uranus ended up rolling on its side or why Jupiter resembles a giant tuxedoed storm, well, at least you'll be learning something as you drift towards sleep. And if you enjoy these quiet scientific journeys, it would mean the world if you tapped the like button and considered subscribing. It's free, and it helps this little starship continue exploring the universe, one sleepy voyage at a time, if you're still awake, which is entirely optional. I'd love to know where you're listening from and what time it is for you. Are you curled up in bed at 10 p.m. in London? Relaxing in a quiet cabin at midnight? Or maybe you're greeting the sunrise on the other side of the planet? Wherever and whenever you are, you're welcome here. There's no rush, no quizzes, just a slow, peaceful wander through the cosmos at your own pace. So go ahead, close your eyes if you'd like. Take a deep breath. And let's begin. 1 star. 8 fascinating worlds. And you, floating gently among them. As with all journeys. Let's start at the center, with the Sun, a brilliant sphere of fire, roughly 400 times farther from Earth than the Moon, and yet 400 times larger, which is why the two appear the same size in our sky. But don't be fooled. The Sun is no small beacon in the sky. It's an enormous, burning engine, over 1 million times the volume of Earth. It serves as the gravitational anchor for our entire solar system. Like a steady parent watching over 8 wildly different children, the Sun is a star. Not especially large among stars, but not especially small either. Astronomers call it a yellow dwarf, though that feels a little unfair for something over 860,000 miles across. At its core, every second, hydrogen atoms are being crushed together under extreme pressure, fusing into helium. This process, nuclear fusion, releases immense energy, which travels outward through the layers of the Sun and eventually radiates into space as sunlight, warmth, and a quiet cosmic reminder to wear sunscreen. It takes light about 8 minutes to reach Earth, so every time you watch a sunrise, you're seeing light that left the Sun 8 minutes earlier. A gentle ghost of a moment just missed. The Sun doesn't have a solid surface. Instead, it's a roiling ocean of plasma, with temperatures around 10 degrees Fahrenheit at the outer layers, but at its core, over 27 million degrees Fahrenheit, hotter than almost anything imaginable. Unless you've ever been stuck in a parked car in July with the windows up. The Sun rotates, too, though not like a solid ball. Because it's made of gas and plasma, its equator spins faster than its poles. A full rotation takes about 25 days at the equator and roughly 35 near the poles. Think of it like a cosmic pancake, one where the syrup swirls faster than the edges, a deliciously chaotic magnetic pancake of fire. Speaking of magnetism, the Sun's magnetic field is intensely active. It produces sunspots, cooler, darker regions formed by twisted magnetic loops, and solar flares, which are enormous outbursts of energy capable of sending charged particles streaking toward Earth. Sometimes solar storms can interfere with satellites, and they're also responsible for auroras, those shimmering lights that dance near the poles. The Sun is constantly churning, bubbling, and occasionally releasing bursts of energy that ripple across the solar system. And yet, despite its immense power, we owe our existence to its steady, dependable glow. The Sun has been shining consistently for about 4.5 billion years, and it's expected to continue for another 5 billion or so. When its life cycle ends, it won't explode in a supernova. It's not massive enough for that. Instead, it will gradually expand into a red giant, shedding its outer layers in a slow, graceful departure. What remains will be a white dwarf, a small, dense core about the size of Earth. But still as massive as the Sun, it will fade slowly, becoming a quiet relic of its former self, but that transformation is far in the future. For now, the Sun is still our guiding star, glowing quietly on the far side of the Earth, reflecting as moonlight, fueling photosynthesis, warming our oceans, and keeping every object in the solar system in motion. It's difficult to overstate the Sun's dominance. It holds more than 99% of the total mass in the solar system, far outweighing all the planets, moons, asteroids, comets, and even distant spacecraft combined. Everything could fit inside the Sun, with plenty of room left over. Even Jupiter, which could contain over 1,000 Earths, is small in comparison to the Sun's enormous scale, and yet we often take it for granted. The Sun rises and sets, or rather we spin, and its steady presence fades into the background. But imagine a sky without it. No seasons, no weather, no life, only cold, dark emptiness. There's something quietly reassuring about its consistency. The same sun that once warmed ancient reptiles is the one that gleams off city windows today, the sunlight that touched your skin. This morning began its journey in the sun's core thousands of years ago. It spent millennia moving outward before finally racing to Earth in just 8 minutes. In many ways, even our experience of time revolves around the sun. Our clocks, calendars, and daily rhythms are all anchored to its presence. We wake with it, we rest when it's gone. And now and then we pause to watch it slip behind the moon, a total eclipse that reminds us of our place in a much larger cosmic story. Ancient civilizations once worshipped the sun, aligning their temples to its rise and fall, telling stories of gods in golden chariots. Today we understand the physics behind it, but perhaps the sense of wonder hasn't fully faded, nor should it. Because while the sun is one of billions of stars in our galaxy, for us, it's home. So as you lie here, gently drifting toward rest, know that the sun's light continues its journey, falling on distant moons, shining through Saturn's rings, lighting up icy comets, and warming our small planet. Just enough to sustain oceans and dreams alike. The sun will still be there in the morning, burning, shining, and holding every orbit in place with quiet strength. You don't have to understand every detail to feel its presence. Just breathe in its warmth and let it guide you to peace. You are part of this system, a sleeper, a dreamer, a mind under a sky lit by a star that has always been with you. Now that we've met the sun, the central force in this celestial dance, let's move gently toward the first planet in its orbit. Mercury. If the solar system were a racetrack, Mercury would be the sprinter circling the sun at high speed, always in motion, never far away. It's the closest planet to the sun, orbiting at an average distance of about 36 million miles, less than half the distance between the Earth and the sun, a close neighbor, though close comes with intense radiation and searing heat. Mercury is the smallest of the 8 major planets, just slightly bigger than Earth's moon. In fact, seen side by side, they look remarkably similar. But Mercury isn't a moon, and it's far from gentle. It's more like a battle-worn veteran, scarred, scorched, and silent. Its surface is covered in craters, cliffs, and hardened lava plains. Like our moon, it's been pummeled by impacts for billions of years, but even more harshly. With no atmosphere to cushion incoming meteors, collisions strike hard and leave deep marks. Imagine a world where time doesn't erase history, where even the oldest wounds remain. Mercury is a planet that remembers everything. Given its proximity to the sun, you might assume Mercury is the hottest planet, but surprisingly, that title belongs to Venus, which we'll visit soon. Mercury does get incredibly hot. Daytime temperatures can exceed 800 degrees Fahrenheit, but without a thick atmosphere to hold the heat, nighttime temperatures drop sharply, down to minus 300 degrees Fahrenheit. That's a temperature swing of more than 1,000 degrees between day and night. You'd need a rather adaptable wardrobe to live there. And speaking of day and night, time on Mercury works in fascinating ways. A full day on Mercury, from one sunrise to the next, lasts about 176 Earth days. So, if you were standing On the surface, watching the sun rise, travel across the sky, and finally set. You'd be there for nearly 6 Earth months. Yet, a year on Mercury, one complete orbit around the sun, takes only 88 Earth days. That's right, Mercury's year is shorter than its day. This unusual rhythm is due to something called a spin-orbit resonance. Mercury spins very slowly, just 1.5 rotations for every full trip it makes around the sun. It's a bit like a planet that can't choose between being fast or slow, so it does both at once. If Mercury were a person, it might dash to the store, then take hours to browse each aisle. If you were standing on its surface, assuming you could survive the heat, radiation, and lack of air, you'd witness some truly bizarre sights. At certain times, the sun would appear to rise, dip below the horizon, and then rise again before continuing its path across the sky. This strange motion is caused by Mercury's highly elliptical orbit and its slow, uneven spin. The sky plays tricks, and nothing behaves quite the way you'd expect. Mercury has no weather, no clouds, rain, or wind. Just quiet. The only movement comes from shadows, which creep slowly across the surface as the distant sun follows its strange route above. But even in this stillness, Mercury isn't completely lifeless. Beneath its solid crust lies a large metallic core, remarkably large, making up about 85% of the planet's radius, far more than Earth's proportion. This giant core generates a weak magnetic field, only about 1% the strength of Earth's, but its presence was unexpected and puzzled scientists for years. There are even more surprises. At Mercury's poles, certain crater floors lie in permanent shadow, shielded from the sun's heat by steep crater walls. Inside these cold, shaded regions, scientists have found what they believe is water ice. Yes, ice on the planet closest to the sun, a hot, dry world hiding pockets of eternal frost. A contradiction, but a compelling one. Humans have visited Mercury, or at least our spacecraft have. The first was Mariner 10 in the 1970s, which managed to capture images of less than half the planet. Then came NASA's Messenger mission, which orbited Mercury for 4 years and gave us our most detailed look yet. Messenger uncovered strange surface hollows, unexpected chemical signatures, and confirmed those hints of polar ice. And more exploration is on the way. The European Space Agency's Bepi Colombo mission, named after Italian scientist Giuseppe Colombo, who helped explain Mercury's spin-orbit resonance, is currently en route. This dual spacecraft is expected to arrive in the early 2030s, ready to further unravel Mercury's mysteries. Mercury takes its name from Roman mythology. Mercury, the swift-footed messenger of the gods. A fitting symbol for a planet that orbits quickly, stays silent, and is always on the move. It's the sprinter that prefers whispers over speed, a traveler who never lingers long in one place. Despite being the closest planet to the sun, Mercury is surprisingly difficult to observe from Earth. It stays near the sun in the sky, visible only briefly at sunrise or sunset, hugging the horizon in short golden glimmers. For centuries, many people never saw it at all. Even today, it's easy to miss unless you know precisely when and where to look, but now, you've visited, if only in your imagination. You've wandered its cratered plains, witnessed its strange double sunrise, and stood in the silent, icy shadows. Mercury isn't a place we dream of colonizing. It's unlikely to host future human life. But it is a planet with a quiet sense of persistence, fast, strange, and enduring. So let's continue, gently warmed by Mercury's faint sunlight, carrying with us the image of a planet that spins slowly, orbits swiftly, and quietly shares its secrets with the solar wind. Earth is the only planet we know of that has liquid water on its surface, an oxygen-rich atmosphere, and a biosphere teeming with life. As far as we can tell, it's the only world that has ever written poetry, baked a cake, or wondered what stars are made of. Our planet is the third from the sun, orbiting at an average distance of about 93 million miles, right within what's known as the habitable zone, or more playfully, the Goldilocks zone. It's not too hot, not too cold, just right for water to stay liquid, clouds to form, and oceans to roll across the surface. Earth measures roughly 7,900 miles in diameter, and consists of several layers: a solid inner core, a liquid outer core, a thick mantle, and a relatively thin crust. That's where we live. But even that crust is always on the move. Earth's surface is divided into tectonic plates that shift, collide, and drift over time. These movements build mountains, trigger earthquakes, and fuel volcanic eruptions, a constant reshaping of a planet that's never truly still. Unlike our rocky neighbors, Mercury and Venus, Earth has an active and complex climate system. Its atmosphere made of nitrogen, oxygen, argon, carbon dioxide, and other trace gases shields life from harmful solar radiation, holds in heat to keep temperatures stable, and drives the water cycle through rain, snow, rivers, and oceans. Weather can be unpredictable, especially when you forget your umbrella, but it's essential to Earth's ability to support life, and when it comes to water, Earth is truly exceptional. About 70% of the planet's surface is covered by oceans, seas, rivers, and lakes. Water continuously moves through a process known as the hydrologic cycle, flowing, freezing, evaporating, and falling again. This abundance of water helps moderate the planet's climate and supports an intricate web of life. But what truly sets Earth apart is life itself. From microscopic bacteria near deep-sea vents to giant redwood trees and migrating whales, Earth is filled with life in all forms. There are glowing animals, carnivorous plants, and fungi that can endure high radiation. Life here is resilient, strange, and endlessly inventive. Among all Earth species, humans stand out for their curiosity and ingenuity. We've built telescopes, sent rockets into space, and asked profound questions. Where did we come from? Are we alone in the universe? And occasionally, is there any chocolate left in the cupboard? Earth's moon also plays a crucial role in our story. It's unusually large compared to our planet, about 1/4 the diameter of Earth, and helps stabilize the tilt of Earth's axis. That tilt gives us our seasons. Without the moon, Earth's tilt could vary wildly over time, leading to more extreme and less stable climates. The moon also drives the tides, pulling at Earth's oceans with its gravity in a rhythm that has influenced life for billions of years. Earth rotates once every 24 hours, giving us day and night. At the same time, it orbits the sun once every 365.25 days. That extra quarter of a day adds up, which is why we insert a leap day every 4 years to keep our calendars aligned. Earth's orbit isn't a perfect circle. It's slightly elliptical. This means we're a bit closer to the sun in January, and a little farther in July, but the seasons aren't caused by our distance from the sun. They result from the tilt of Earth's axis. When your hemisphere is tilted toward the sun, it's summer. When it tilts away, it's winter, regardless of how far Earth is from the center of the solar system. Let's not pretend Earth is flawless. It's a bit unpredictable. Hurricanes, earthquakes, and volcanic eruptions remind us that our planet is both stunning and unstable. Human activity, especially over the last 2 centuries, has brought its own set of challenges: climate change, pollution, and the ongoing loss of biodiversity. Yet even with all this, Earth remains remarkably generous. There's something quietly poetic about how Earth often goes unseen from much of the solar system. From Mercury, Venus, or Mars, it may look like just another bright dot in the night sky, offering no hint of its oceans, forests, or cities filled with laughter. From Jupiter and farther out, it fades to a dim, pale speck. When Voyager 1 turned back and captured that now iconic image of Earth, a tiny blue dot suspended in a sunbeam, Carl Sagan famously called it the pale blue dot. It served as a reminder of how delicate and irreplaceable our world really is. It's humbling to think that everything you've experienced, every memory, every person, every meal has taken place on this one small sphere spinning through space. Earth isn't just a planet. It's the only home we've ever known. A world where atoms bonded into molecules, molecules formed cells, and somehow from all of that came language, music, and imagination. Seen from space, Earth reveals no political boundaries, no noise, just swirling white clouds, deep blue oceans, and textured landmasses drifting across its surface. Astronauts often describe a powerful shift in perspective when they see Earth from orbit, a realization that, from above, our differences seem smaller, and that all of us share this fragile spacecraft as it journeys through the cosmos. So as you lie here now, breathing softly, allow yourself to feel Earth's presence, not just its gravity, but its connection to you. You are made of the same elements: carbon, oxygen, nitrogen, and you are part of this planet's story, shaped by its ecosystems, lit by its sun and held gently by its magnetic field, and as Earth quietly spins beneath the stars, it continues to sustain and protect us, whispering stories of its ancient seas and drifting continents. In every way, it is our mother world. Rest easy knowing that beneath you lies a living, breathing planet, and above you, the stars still shine. They are distant, yes, but never beyond reach for a curious mind. Now, we leave the familiar warmth of Earth and set our course toward a world that has long captured the imagination of scientists, dreamers, and storytellers alike. Mars. Mars is the fourth planet from the Sun, orbiting just beyond Earth in the cold, rust-colored outer region of the solar system. It's often called the Red Planet, and with good reason. Its surface is rich in iron oxide or rust, which gives it a dusty, reddish appearance. From far away, it resembles a glowing ember, dimly lit in the darkness. But up close, Mars is a world of deep canyons, ancient craters, frozen deserts, and dry riverbeds, a landscape that once may have seemed a bit like home. Mars is roughly half the size of Earth, with a diameter of about 4,200 miles. Its gravity is just 38% of Earth's, so if you weigh 100 pounds here, you'd weigh only 38 pounds on Mars. You'd walk with a spring in your step, leap higher, and carry your bags with ease. Mars is cold and arid. Average surface temperatures hover around minus 80 degrees Fahrenheit, and near the poles it can plunge to minus 200. Unlike Mercury or the Moon, Mars has an atmosphere, thin but still present. It's made mostly of carbon dioxide with traces of nitrogen and argon. There's virtually no oxygen, so taking a breath on Mars without support would be extremely dangerous. You'd need a durable spacesuit and a steady oxygen supply. Still, the sky above would appear softly orange, and the sun would rise and set like a faint golden ember. One of the most distinctive aspects of Mars is its terrain, planet defined by extremes. Olympus Mons, the tallest volcano in the solar system, towers about 75,000 feet high, almost 3 times the height of Mount Everest. Then there's Valles Marineris, a vast canyon system stretching over 2,500 miles across the planet, roughly the width of the continental United States. In some places it plunges over 4 miles deep, as if the surface had cracked open to expose the planet's ancient and restless interior. But perhaps the most intriguing part of Mars isn't what we see today, it's what the planet might have been. There's compelling evidence that liquid water once flowed across its surface. Ancient river channels, deltas, and lakebeds suggest that Mars once had a denser atmosphere and a more temperate environment. Some researchers even speculate that large oceans may have once covered much of the northern hemisphere. Currently, most of Mars's water is locked in ice at the poles or stored underground as frozen reserves. But during certain Martian seasons, dark streaks known as recurring slope linea appear on some hillsides. These may be caused by salty brine water slowly seeping up from beneath the surface. It's far from tropical, but it raises a critical question. Could microscopic, resilient life still exist beneath the Martian dust? Mars has 2 small moons, Phobos and Deimos. Both are irregular in shape, likely captured asteroids, and look more like lumpy rocks than traditional moons. Phobos, the larger of the two, orbits Mars so quickly that it rises and sets twice each Martian day. In time, perhaps within 30 to 50 million years, Phobos is expected to either crash into Mars or break apart into a ring, but there's no need to worry just yet. A day on Mars, called a sol, is strikingly similar to an Earth day, about 24 hours and 39 minutes. However, a Martian year is much longer. It takes about 687 Earth days for Mars to complete one orbit around the Sun. That means your birthdays would come around less often, but your daily rhythm would feel surprisingly normal, like Earth. Mars has seasons due to its axial tilt, which is around 25 degrees. It experiences spring, summer, autumn, and winter, though each season lasts longer because of the extended orbit. In Martian winters, carbon dioxide in the atmosphere freezes and falls as dry ice snow at the poles. Imagine snowflakes made of frozen gas drifting down from an alien sky. The idea of living on Mars has fascinated people for centuries. Early astronomers believed they saw canals possibly engineered by intelligent life. These turned out to be optical illusions, but the idea stuck. Today, Mars remains a key focus for future exploration and possibly one day human settlement. Over recent decades, we've sent numerous robotic missions to Mars. Rovers like Spirit, Opportunity, Curiosity, and Perseverance have explored its surface, snapping images, analyzing rocks, and hunting for signs of ancient life. The Ingenuity helicopter, a small solar-powered drone, became the first aircraft to fly on another world. Flitting through Mars's thin atmosphere like a robotic dragonfly, these missions have revealed a lot. We've found complex organic molecules in the soil, short-term methane spikes in the air, and signs of long-gone hydrothermal activity. We've even started testing ways to convert carbon dioxide in the Martian atmosphere into breathable oxygen, a small but vital step toward human survival. Why does Mars matter so much to us? Perhaps because it's near enough to reach challenging, but not impossible. It's familiar, yet alien, a potential new frontier. A reflection of what Earth once was, and perhaps a glimpse into what it could become. Mars reminds us that planets evolve, they cool, dry out, and change. And maybe with the right steps, they can be brought back to life. From Earth, Mars appears as a reddish dot in the night sky. But up close, it's a dusty relic from a time long past, a world of ancient rivers, massive volcanoes, and the potential for life still waiting to be found beneath its surface. So picture yourself there, standing on a windswept plain under a pale pink sky. Unlike Mercury or the Moon, Mars has an atmosphere thin but still there. It's made mostly of carbon dioxide, with small amounts of nitrogen and argon. There's almost no oxygen, so breathing unaided on Mars would be extremely dangerous. You'd need a strong spacesuit and a steady oxygen supply. Still, the sky would appear softly orange, and the sun would rise and set like a faint golden ember. Mars is known for its dramatic terrain. It's a planet of extremes. Olympus Mons, the tallest volcano in the solar system, stands around 75,000 feet high, nearly 3 times the height of Mount Everest. Then there's Valles Marineris, a canyon system so massive it spans more than 2,500 miles, about as wide as the continental United States. In some areas, it drops over 4 miles deep, as though the surface split open, revealing the planet's ancient, unsettled interior. But perhaps the most fascinating thing about Mars isn't what it is now, but what it may have been. There's strong evidence that liquid water once moved across its surface. Old riverbeds, deltas, and lake basins suggest that Mars once had a thicker atmosphere and a milder climate. Some researchers believe vast oceans may have covered much of the northern hemisphere. Today, most of Mars's water is frozen either in polar ice caps or buried underground. But during certain times of the year, dark streaks called recurring slope linea appear on some slopes. These may be caused by salty brine water slowly seeping up from beneath the surface. It's not exactly tropical, but it's enough to raise an important question. Could tiny, resilient life forms still survive beneath the Martian dust? Mars also has 2 small moons, Phobos and Deimos. They're irregular in shape, likely captured asteroids, and look more like oversized potatoes than the round moons we're familiar with. Phobos, the larger moon, orbits Mars so quickly that it rises and sets twice each Martian day. Over the next 30 to 50 million years, it's expected to either crash into Mars or break apart and form a ring, but that won't happen anytime soon. Day on Mars, known as a sol, is surprisingly close to an Earth day, lasting about 24 hours and 39 minutes. A Martian year, however, is much longer. It takes around 687 Earth days for Mars to complete one trip around the Sun, so While your days would feel familiar, your birthdays would come around less often. Mars also experiences seasons, much like Earth, thanks to a similar axial tilt about 25 degrees. It has a Martian spring, summer, autumn, and winter, although each season lasts longer due to the planet's longer orbit. In winter, carbon dioxide in the atmosphere freezes and falls as dry ice snow at the poles, snowflakes made not of water, but of solid gas. The idea of life on Mars has intrigued people for centuries. Early astronomers thought they saw canals, perhaps, built by intelligent beings. These were later revealed to be optical illusions, but the fascination with Mars never faded. Today, it remains a leading candidate for future exploration and possibly even human settlement. Over the past few decades, we've sent many robotic missions to Mars. Rovers like Spirit, Opportunity, Curiosity, and Perseverance have rolled across the planet's surface, capturing images, drilling into rock, and analyzing signs of ancient life. The Ingenuity helicopter, a small solar-powered drone, became the first aircraft to fly on another planet, hopping through Mars's thin air like a robotic insect. These missions have revealed a great deal. We've discovered complex organic molecules in the soil, detected short-lived methane emissions in the air, and found signs of ancient hydrothermal systems. We've even started testing technology to turn carbon dioxide from the Martian atmosphere into oxygen, a small but critical step toward making human presence possible. Why does Mars matter to us? Perhaps because it feels within reach. It's challenging, but not out of the question. It's both familiar and unfamiliar, a planet that could represent our past and possibly our future. Mars reminds us that planets can change. They can cool, dry out, and evolve. And maybe, with enough effort, they can be restored. From Earth, Mars appears as a faint red point in the sky. But up close, it's a dusty relic from the early solar system, a place shaped by water, fire, and time, and perhaps still home to hidden life. So picture yourself there, standing on a barren plain beneath a pale, pink sky.